Welcome guys to the first video. If you feel like you needed to brush up on something before your tests or exams, may you find these videos helpful because I'm going to go through the theories with you and also examples from past papers, questions, or those that I feel like that will prepare you for any question or exam. Okay, so let's start. We're going to start with limits first. So what's a limit? Nothing better than starting with the definition. So f of x, which is our function, is defined when x is near a number a, that's basically on our x-axis, then the limit of f of x as x approaches that same number on the x-axis equals to L. That's what our f of x equals to on the y-axis. Yes, so this is the notation we write. The limit of f of x as x approaches a is equal to L. So example here. A is basically our 1 in this example. So as x approaches 1, which is A, from either side, the left or the right, then our function f of x is going to approach 2. Then we write the limit as x approaches 1 of f of x, let's write meter, of f of x is equal to 2. That's our answer. That's basically the limit of this function at a particular open interval. Note that this has to be an open interval and it will be shown like this, open interval. Okay, next, why do we need limits? So basically, if you want to calculate the tangent, this is our secant lines, as you can see, and the smaller and smaller the interval gets for our secant lines, the more and more secant lines we draw, we're going to be approaching a value c, which is our most approximate, most precise value to the tangent, which is our slope at the curve. Okay? Or if you want to calculate the area, then you can draw as many small rectangles and fit them in between these 2 points, between A and B on our x-axis. And if you calculate the sum of the area by summing the areas of many rectangles, you're going to find an approximation. And the smaller and smaller rectangles, the smaller and smaller the width you make the rectangles, the better our approximation of calculating the area. Alright? So we say the limit of a function f at a point c, we just denoted that particular point c, is equal to L if and only if f of x is near L. As you can see, f of x is near L, doesn't have to be defined. That's what they basically mean. It's near 2, but doesn't have to be defined at 2. So, whenever x is near c, so it's going to be approaching a value on the y-axis, which is our L, whenever x is approaching a particular value on the x-axis. Alright, and this is our notation that you should get used to when writing. Alright, let's look at an example. So the limit as x approaches 4, from the left or the right, is going to be approaching a particular value on the y-axis. As you can see, our f of x, as x approaches 4 from the left and the right, is going to be approaching 2. That's our answer. And you should know it exists when the left and the right limits are both equal. In another example, when left and right limits are both equal, is when x approaches 3. From the left, you can see that the function g is approaching a particular value minus 3. And from the right, you can see that our function g is approaching the same value. Since our limit on the left and the right are approaching the same value, we say the limit exists. For the limit to exist, that means that the limit as x approaches 3 of g of x is equal to minus 3. Now, what about when you have a discontinuity here, where it's not defined here, shown by an open dot, by an open interval here, and it's defined on top, above. So what can you say about the limit as x approaches minus 3? Well, from the left, as x approaches minus 3, h is going to be approaching 102. Well, remember, it doesn't have to necessarily be equal to 2. That's why, if you remember, we said it is going to be near L. Near L. But it can be equal to L. It also doesn't have to be equal to L. So in this example, it's going to be 1. So the limit as x approaches minus 3 from the left, this is how you write it, x approaches minus 3 from the left of h of x is going to equal to 1. Same for the right side. The limit as x approaches minus 3 from the right, you write it the same way, but you just make it plus. That means the right is also going to be approaching the same value, 1. That means the limit exists, and the limit as x approaches minus 3 of h of x is equal to 1. Alright, what about when there's a discontinuity? Here, a jump discontinuity. That's what we say. What is the limit as x approaches minus 2 from the left? So as x is approaching minus 2, you can see that the graph is approaching minus 2. So the limit as x approaches minus 2 from the left is equal to minus 2. What about the right? We say that the limit as x approaches minus 2 from the right isn't going to be approaching the same number. No, it's going to be approaching minus 1 is equal to minus 1. Since the left-hand limit is not equal to the right-hand limit, we say that the limit does not exist. Therefore, the limit as x approaches minus 2 from the left and the right here does not exist for p of x.